Go ahead, Mehmet.
Thank you, Dina. Good evening. I'm Mehmet Ansoy, Vice President of Denver Astronomical Society. This evening, we have the pleasure of having Dr. Jack Burns with us to talk about the lunar frontier. Dr. Burns is a professor of astrophysics, professor of physics, and Vice President Emeritus at the University of Colorado. He is director of the NASA-funded S-Survey Network for Exploration and Space Science. And Dr. Burns has served in multiple administrative positions, including Vice President for Academic Affairs, Vice Provost for Research, Associate Dean, and Department Head at 4 universities. Early in his career, he was a postdoctoral fellow at the National Radio Astronomy Observatory. Dr. Burns has over 500 publications listed in NASA's Astrophysics Data System. Dr. Burns is an elected fellow of the American Physical Society, the American Association for the Advancement of Sciences, the American Astronomical Society, AAS, and a fellow of the International Academy of Astronautics. He received NASA's Exceptional Public Service Medal in 2010 and NASA's Group Achievement Award for Surface Telerobotics in 2014. He has been a member of NASA's Presidential Transition Team, and he has also served as Vice President of the AAS, Chair of the AAS Committee on Astronomy and Public Policy, and on the NASA Advisory Council. Dr. Burns, please proceed with your presentation.
Very good. Thank you, Mehmet, and thank you for the invitation to be with you all tonight. As Mehmet said, the title of my talk tonight is The Lunar Frontier. And we're talking about really the new lunar frontier, because, of course, 50 years ago, we did visit the moon briefly with the Apollo missions. There was a total of 6 Apollo missions that went to the surface of the moon. And finally, after 50 years waiting, because the last Apollo mission was in December of 1972, we're in the process of new journeys to the moon. In particular, I don't like to talk about going back to the moon, because going back to the moon would suggest we're going to just revisit the things that we've already done. Instead, I like to call this going forward to the moon, as you see the little emblem here. And this is actually the name of a new planetarium show that we developed for the Fisk Planetarium and has been distributed nationally and internationally now. And it's a show that captures some of the things I'm going to be talking about today. I urge those of you that can get up to Boulder. This show is on regular play and shown a couple times a week. And I think it's going to be at the Denver Museum of Science and Nature sometime soon as well. So these new voyages to the moon are, not your grandfather's Apollo program. I mean, these are, we're looking at 50 years of additional technologies. I sometimes refer to this as taking Silicon Valley to the moon. All of the information technology, the robotics, the advanced computer technology, that's going with us to the moon. And that is going to open up a whole new range of science that we can do, some astronomical science, some radio astronomy that I'm going to talk about tonight, but also exploration, mining water from the moon and other resources that we want to talk about today. So these are indeed new adventures. And the timing of my talk tonight is good because, of course, we're getting ready to see the first launch, hopefully in a few weeks, of Artemis 1. But the one thing I would emphasize that hasn't changed since the 1960s is that the space program must continue to, see if I can advance my slide here, must continue to inspire the next generation. This is a picture of my grandson, Jackson. This is actually a couple of years ago. Now, at our age, we have to show pictures of our grandchildren, right? I mean, we can't do a presentation without pictures. He's dressed up in a spacesuit. But the Apollo program and the Mercury program and the Gemini program inspired me to become a scientist. And this has happened for several generations of folks. We must continue to use the space program as a way of motivating people to study the STEM field, science, technology, and engineering and mathematics. So all of that is important, and that mustn't change in going forward. All right, so our new voyages to the moon, NASA is calling this Artemis. Artemis in Greek mythology is the twin sister of Apollo. And that's appropriate because NASA stated that in the first landings on the moon, these first human landings in the 21st century, that we're going to be bringing the first woman and the first person of color to the surface of the moon. So much more diversity, much more open than was true in the 60s and 70s. This picture that you're seeing here from NASA, is a cartoon picture showing the human program at the top, and then on the surface, the unmanned science program. Both are going forward simultaneously and much more ambitious than Apollo. We've already mentioned Artemis 1, which we're hoping to see fly later this month. It is going to be a test run, a test of launch of the Space Launch System, the new powerful rocket, along with the Orion spacecraft that was designed and built right here in Colorado by Lockheed Martin. So Colorado is playing a really important role in this. This will orbit the moon, spend about 35 days, return, test the heat shield, and all the new components. About 2 years from now, Artemis 2 will fly with the first crew. It will not go to the surface. This, once again, will be an orbiting mission. And then finally, about mid-decade, will be Artemis 3, where we will have those first astronauts of the 21st century on the moon, and they'll be going to the South Pole of the moon. In the meantime, NASA's Science Mission Directorate has a whole series of new unmanned landers that are getting ready to go to the moon as part of what they call the Commercial Lunar Payloads Services Program. This is very exciting because it's a part of these new public-private partnership. NASA is not building these landers, rather they're contracting with companies outside of NASA to bring NASA-funded payloads to the surface of the moon. And I have 2 such payloads on board 2 of the upcoming landers that I'll tell you about. One is going to land in January, so just a few months away. But a whole series of these will continue. 2 per year is what the plan is, starting next year in 2023. So let me show you a little clip, actually, from our planetarium show, Forward to the Moon. This is the reason it has this sort of strange circular view, because it's meant to be on a planetarium dome. And again, I urge you to come and actually see it. But this was our visualization of what we hope the Artemis launch will look like in a few weeks. The narrator is Carrie Byram. Some of you might recognize from the show Mythbusters from a few years ago. So let me go ahead and play this for you, just a short clip. Oops, sorry.
With everything in place, it'll be time to start a new chapter in our history. For the Artemis 3 mission to take humans to the moon's surface.
5, 4, 3, 2.
After those first astronauts have proven this new route to the moon, what will we make of this opportunity? How might a moon base camp look years after we return to the lunar surface? There may be large structures for mining facilities, geological research, and transportation networks for materials and inhabitants. The materials and resources found on the moon will also be important for sustained exploration of the lunar surface. Astronauts will periodically venture out on the surface in spacesuits, their own personal spacecraft. On the moon, there are many dangers. The vacuum of space, drastic temperature changes, abrasive moon dust, and space radiation are just some of the challenges. So, for much of their stay, astronauts will be protected inside habitats underneath the lunar regolith. It's safer below the surface of the moon. From here, they will use telerobotics to control robots up on the lunar surface.
Well, yeah.
It's also safer.
So I hope you can envision this on the planetarium dome and go see this in Boulder, because this is the closest thing you're going to get to space. It really does feel like you're a part of this. So I think again, this just gives you a little bit of flavor of what we're looking at in some of the new technologies. And this is a picture of me actually in front of the rocket just a few months ago. We had a conference at Cape Canaveral on unique science from the moon in the Artemis era. And I was given an opportunity to go out to the launch pad. This was when they were testing this summer. They were doing a dry run of fueling. It's called a wet dress rehearsal. They were fueling up the rockets and testing it out before the launch, which is taking place now. It is a massive rocket. It is 15 times more capable, 15%, I should say, more capable than the Saturn V. All of this rocket is fuel, all to take this tiny little capsule right on top here, which will have 4 astronauts eventually to the moon. It takes a lot to get off of the Earth into space. This is given by what's called the rocket equation. This is what I'm teaching my students right now in our space science and space policy class. And it takes a massive beast like this to make it to the moon. That Orion spacecraft is very new, although it may at first glance look very similar to Apollo. And this is a comparison between Apollo on the left and Orion on the right. To first order, it may look similar. Both are kind of capsules. Both have these what are called ablative heat shields, because that's the safest way to return to the Earth. But remember, the spacecraft is coming back to the Earth at 25,000 miles per hour. And so the heat is intense when the spacecraft enters into the atmosphere. This will protect the astronauts. But other than that, the 2 spacecraft are really different. Apollo carried 3 crew members. Orion will be capable of carrying 4. Longer duration stays with Orion. Fuel cells did the powering for Apollo, but you remember there were some problems. Apollo 13, we mentioned, had an explosion. We're going to have a simpler solar array powered system. The service module, which is in the back here, that has the engines that will take the crew from the moon back to the Earth, and also the power, is actually being provided by ESA, the European Space Agency. So here's another difference between Apollo and Orion. Right out of the gate, this is an international collaboration between NASA and the European Space Agency. The other thing that's different about Artemis is that NASA is with international partners, including Canada and the Japanese Space Agency, are building something called the Lunar Gateway, kind of like a space station, although really more of a space vehicle in orbit. I say it's more of a space vehicle because it has this new engine that will be using a different kind of propulsion system. called solar electric propulsion that will be tested out, and eventually we hope to be able to use for Mars missions. But this is where the Orion space capsule will dock. Astronauts will then transfer to a lander, a reusable lander that will go down to the surface, hopefully get refueled using water, which has been mined from the moon and reprocessed into rocket fuel, and to be able to go back and forth. This should lead to more long duration and more reusability associated with this system. So that part is new. Let me show you another video clip from our Forward to the Moon that shows you a little bit more about this gateway.
Astronauts, about 5 days to reach it. Every moment, trusting their lives to the hundreds of engineers who designed and built Orion's protective systems. Beyond Earth's magnetic field, the spacecraft will be exposed to the dangers of deep space. Intense radiation and high-speed particles from the sun can damage both electronics and human bodies. Artemis has been designed with these challenges in mind to bring our astronauts safely back to Earth. Artemis is not an end in itself, but just the first step towards a sustainable future in space. For this reason, NASA is leading development of an orbiting spaceport called the Lunar Gateway. The Gateway provides a rendezvous point for landers, cargo, and supplies needed to support operations on the lunar surface, and extra living space for visiting astronauts. Constructed by robotic missions in years leading up to the astronauts' arrival, it will be used by both crewed and robotic spacecraft. The Gateway has an unusual...
So again, that's a little bit of a sample of some of the new aspects of the human program going to the moon. The other thing that's different about Artemis is we're going to be going to vastly different places on the moon. With Apollo, we are very limited to a few sites at mid-latitudes on the near side. With Artemis, we'll be going to the poles, and we will be going to the far side of the moon. And most of you recognize that our moon is what's called tidally locked. So one side is always facing us. We see the famous man in the moon, and then the other side, which we never see from Earth, and you see a picture of it here. This is actually a topographic. It's colored by elevation that you see over here. Is very different than the near side. It has this large impact basin, which is colored in blue. That's low elevations here, called the South Pole Aitken Basin. But the far side is also wonderful from astronomers' perspective, like myself, because it blocks radio interference coming from the Earth, and it is the only truly radio quiet environment in the inner solar system. And this is what we're going to take advantage of with our upcoming CLIPS missions that are underway. So let me tell you a little bit now about our first radio astronomy from the moon. Our very first mission, which is going to fly in January, is called ROLS's, and that's actually an acronym and sort of complex acronym here, talking about observing from the lunar surface something called the photoelectron sheath. What that really is we're trying to measure for the first time the ionosphere close, the very tenuous ionosphere that's close to the surface of the moon. And that's produced as a result of the interaction of the solar wind with the lunar soil called the regolith. Here's a picture in the upper left of the spacecraft being built, the lander being built by Intuitive Machines in Houston. And our radio telescope is very simple. It doesn't look like what you think of a radio or radio dish. It's just these 4 monopole antennas that form 2 cross dipoles. So think of this in terms of, enough of you are old enough to remember TV antennas up on your roof, okay? Same kind of lower frequencies that we're operating here. We're going to be operating between actually down to 10 kilohertz up to 30 megahertz. So well below the FM band. So below a frequency that can be seen from the Earth. So the technology is simple. It's actually flown in space before, but not on the moon. It has, the antennas are just these hollow tube antennas called stasers. And this is the actual antennas that we've delivered to Houston in the stowed capability. They're just spring loaded. And when we reach the surface, we open it up and the antennas just pop out. Very simple. The guts of the instrument is this spectrometer board. So a lot of electronics here to be able to measure spectrum. We're really not going to have any resolution, angular resolution on the sky. So we'll be taking a spectrum. This is what's going to get us the data that we're interested in. So this was one of the this was in fact the very first instrument selected to go to the moon when there was a call in 2018, 2019 for NASA related instruments. And so I teamed up with my colleagues at the NASA Goddard Space Flight Center. We proposed this instrument and it was selected. It's a new build, but it's based on a lot of heritage from several other NASA missions called Stereo Waves and SMAP. And I've already talked about the frequency of that. And so it's operating at very low frequencies below the Earth's ionospheric cutoff. So you couldn't, even without radio frequency interference, you couldn't do these from the surface of the Earth because the radio waves, these frequencies don't penetrate. So this is scheduled to land on the moon with an Intuitive Machines Nova C lander. So this is one of these CLPS or Commercial Lunar Payload Services landers. So let me show you a video of what we hope this landing is going to look like in a few months. This is from Intuitive Machines.
Acquisition of signal and lunar orbit insertion complete.
HDA scanning in progress. Safe sites found.
Prepare for landing.
So fingers crossed it'll be that smooth. But of course, it's the first time out. But this is going to also be seriously cool from one aspect of cameras. We're going to have a series of cameras on the upper deck taking images as we are landing. And in addition, another commercial company, a non-NASA company, is going to bring a couple of these small CubeSats with cameras. And those are going to be ejected from the spacecraft and then take images of the lander as it's going to the surface. This will be the first time ever that we're able to watch the landing of a spacecraft on an extraterrestrial body from outside the spacecraft. So hopefully we'll have some very nice video. I can come back and tell you guys all about it when hopefully we have a successful landing. So that's our first mission. It's actually going to be on the near side of the moon to begin with, and it'll allow us to get started. It's going to launch, as I said, early 2023. Here's a couple of pictures of me at the Intuitive Machines operation in March of this year. So on the left-hand side is a full-scale mock-up of the spacecraft. See the two large propulsion tanks, hydrogen and oxygen, basically, and our payload is strapped onto the side. And then another picture of a former graduate student of mine who is now at the NASA Johnson Space Center in the NOVA control room that has been put together by Intuitive Machines. I hope to be in that control room in January monitoring the landing that will hopefully successfully take place. So stay tuned. We'll see how this goes in just a few months. The second mission, which is already funded and manifested, will be the first radio telescope to go to the far side of the moon. And this is called Lucy, the Lunar Surface Electromagnetic Experiment. And this one is particularly exciting because we're going to have enough batteries on board to be able to operate through the night, which is the most quiet time where we will be doing observations of the very early universe for the first time. This Farside radio telescope is going to allow us to start looking at a part of the universe that has never been surveyed before, called the Dark Ages. So take a look down at the bottom here. You see a cartoon picture of the evolution of the universe. Big Bang over on the left, today's universe 13.8 years later on the right. It's the time, it's logarithmic time at the bottom. We sort of start off over here with results from the cosmic microwave background. This is when the universe has cooled to the point where electrons and protons combine and produce the first hydrogen atoms. So the universe is full of neutral hydrogen, but there are no compact sources of radiation yet. No stars, no galaxies, but those things are beginning to collapse. This is called the Dark Ages. And telescopes like Webb and Hubble can't survey this early time in the universe because there are no sources of optical or ultraviolet radiation. But the neutral hydrogen produces, by the time we receive it, low frequency radio emission. So we can actually sample this time period with our radio telescope and watch as those first stars and galaxies are collapsing, and also explore more exotic physics having to do with dark matter and dark energy processes. So this telescope is on the surface of the moon, on the far side of the moon, is uniquely suited to doing those kind of observations. So not only do we open up a new wavelength window to the cosmos that we haven't observed that before, we open up a new epoch in the cosmos as well that we'll be observing. So that's going to be very exciting and a lot of fun. But that's not the end of the story. We have then plans for additional telescopes. What we're really building towards is to put an array of radio telescopes onto the moon. Some of you may know about the VLA, the Very Large Array Radio Telescope near Socorro, New Mexico. I started off my career there when the VLA was just getting started. What we're doing is kind of putting down a low frequency simplified version of the VLA onto the moon using these rovers and with the radio telescopes inside these tethers. The mission is called Farside, and it's to do investigations not only of the Dark Ages, but also exoplanets that are around stars like this one. This is an M dwarf star that is bursting with an exoplanet in a magnetic field radiating low frequency radio emission. So we can use such arrays to not only explore the early universe, but also to explore exoplanets, another aspect of exoplanets. Okay, let's think about this for just a moment. So let's do a comparison in our own solar system between the Earth and Mars. Those two planets have taken very different evolutionary paths. Why? Well, the MAVEN spacecraft that we built at the University of Colorado with Lockheed Martin has shown us that the solar wind has stripped the atmosphere of Mars over time. And the reason that happened is because the magnetic field, which was early on protecting Mars for the first couple of billion years, it shut down. It's the core got too cold to maintain a dynamo, and it shut down. So Mars went from, here's a highly stylized picture of Mars in the first 2 billion years with liquid water on the surface. maybe life forming, to the desert planet that it is today because it has been stripped. So magnetic fields may be very important for life to be present. So we have a tool with our low frequency radio telescopes now to actually search and detect magnetic fields on those exoplanets because they radiate at low radio frequencies. So that's one of the goals that we're pursuing with this array. We've been working with the Blue Origin company, Jeff Bezos' company, in the lander that they are building for the moon. And here you see a cartoon picture with 4 of our rovers on the top and all of our instruments up there. We need to deliver about 1.5 metric tons to the surface to be able to do the mission. And once it's on the surface, then the rovers are deployed from the top, lowered through the tethers, and they stretch these tethers out to a diameter of 10 kilometers in total, with, as I'll talk about in a moment, the antennas are inside the tethers. And we put it out in this spiral pattern because that creates a nice synthetic aperture, which we use for the radio telescope. So just a little bit about how we stow these on here. You can see these packed in this configuration. Then upon landing, it's just spring loaded. We release the springs. They pop out the rovers, and then we lower them down to the surface. And these tethers have power. They will have optical fiber, and the individual antennas and receivers are actually embedded in there. Here, this little white spot here would indicate where one of the receivers is, and the antennas are just wires. Okay, they're 10 meter to 100 meter diameter wire, length wires that are in there. So very, very simple technology, very simple antennas in comparison to something like the VLA, but at low radio frequencies, that's all you need. So a relatively simple mission that is practical to do by the end of this decade. Just to give you an idea of the size of these rovers, once again, we've been working with JPL in Pasadena. So these are large rovers. The spool is, we wrap the tethers around, and embedded in the tethers are the receiver and the electronics. They're good size at 2.3 meters. So the rover is even bigger than Elon Musk. And I would argue even bigger than his ego, to take us to the moon and do what we need to do on the surface of the moon. We've done a series of test runs already of deploying these tethers on the moon, and we have done that successfully. A few years ago, we ran, let me just forward here. We ran another test actually from the International Space Station with working in conjunction with the NASA Ames Research Center. My students and I built this deployer on this rover that you see here called K10. And this is a Kapton material that would be forming the tether. And what you're looking at is astronaut Luca Parmentano out here. This is actually a video. If you look carefully, you can see it moving. He's using our software that we designed to navigate across the surface. He is operating the rover directly from the space station. This was the first time that an astronaut had operated a surface rover from space. Now, granted, it was Earth, surface of the Earth to the space station, but it demonstrated the capability of being able to do that remotely. So, that's an exciting advance showing the technology is moving along. This technology also offers wonderful opportunities for our students. And here's a rover that my students and I have built with a mechanical arm and a camera that is operational. It has just a simple Xbox controller. And these are projects with undergraduate students that we're working on. We've then put these all into the computer as well, and developed a virtual reality version. We have this mini stereoscopic camera, and then we can operate it using a headset, like what we see here, to teleoperate. Here's one of my students showing the stereoscopic camera that's linked to the headset, and then you can see that he's actually operating the headset and the rover in this form. So this is the kind of technology that will next be available. My students then took this. Now this is a digital version, and we put this into the computer. It looks very much like the real McCoy, and using the same software that operates the mechanical version, we have digitized it. And of course, we can, with the virtual and virtual reality, we can then operate it on the moon, do rapid prototyping, testing, problem solving for when we're deploying our telescopes on the moon. So this is, once again, exciting opportunities, and it's really given my students wonderful job opportunities after they graduate. So one last project that I want to talk about, another radio project. As you can see, we're getting increasingly more complex with time. This is a project for the 2030s called Farview. And this is 100,000 dipole antennas that we want to put down onto the surface of the Farside. This is the ultimate telescope for doing the kind of cosmology that I talked about earlier to sample the dark ages. To do that, though, you can't haul all of this from the Earth. And so what we're proposing, what we've teamed up with a company called Lunar Resources in Houston, Texas, to actually manufacture the antennas from aluminum and other materials that we extract from the lunar soil using an electrolysis process, and then plating those telescopes on the moon. Let me show you a little video of that process, and then we'll wrap up at this point.
Farview is a next-generation astrophysics radio observatory built on the moon's far side. The only radio-quiet place within the inner solar system to study the earliest stages of evolution of the universe. The Lunar Observatory will be built from Lunar Resources and constructed directly on the surface of the moon using space industrial equipment sent from Earth. The required materials will be extracted by Lunar Resources manufacturing technologies from the lunar regolith. A truck rover then delivers the extracted raw metals to the construction site for the fabrication of antenna elements, solar cells, electrical transmission cables, and batteries. The observatory's antenna array and power grid is then assembled directly onto the surface of the moon, utilizing Lunar Resources space manufacturing technologies and its partners' intelligent lunar rovers. Farview is estimated to be a 10 by 10 kilometer observatory with 100,000 dipole antennas and will take less than 4 years to be constructed. The Lunar Observatory will explore the origins of the first structures in the universe, opening new science windows into low-frequency radio astronomy, seeking to uncover new physics and test standard cosmological models, and enable new science in heliophysics and planetary science. Farview will be one of the most powerful radio observatories for learning about our universe.
So you can see we have grand ambitions. We're not shy about what we would like to do. And a lot of this technology that is being built for Artemis, Commercial Lunar Payload Services Program, all of this does feed forward to eventual missions to Mars. When we learn how to live and work on the moon, which is only 3 to 5 days away, then being able to apply this to eventually go to Mars, which is more like an 8-month journey, is important. But what we're looking forward to in the short term is to indeed go forward to the moon. With that, I'm going to stop there and be happy to take some questions.
Thank you, Dr. Burns. This was a very informative, excellent presentation. Thank you. We have several questions here, but I'll start with my simple question and then ask the others to voice their questions. My question is, you talked about Artemis 1, 2, and 3. What can you tell us, or do you have anything to tell us about Artemis 4 and beyond?
Yes, I mean, because NASA has plans. Again, what's different with Artemis versus Apollo is Apollo was not sustainable. And Apollo was driven by political goals, beating the old Soviet Union to the moon. Once that was done and those political goals were met, there really wasn't a lot of reason from the Nixon White House at that point, who canceled the Apollo program, to continue it. Today, we are looking to become a permanent spacefaring civilization. And that means sustainability on the moon and moving forward. So Artemis 4, 5, 6 will start building small bases on the moon, like what you saw in one of the videos I showed, in which this will be similar to stations like the McMurdo station in the Antarctic, where people winter over sometimes and stay for months or even years. The same would be true on the moon. And it would also then have industrial facilities and for mining and manufacturing on the surface of the moon. So NASA's view is, and along with ESA, JAXA, and the other space agencies, is to develop this in collaboration with the private sector for the long term.
Thank you. The first question actually is from Dina. Dina, would you like to ask your question?
Yes, my question is about the orbit of the vehicle that's going to be staying in orbit around the moon. Will it be round or highly elliptical? How will it facilitate the landing at the different landing sites?
Yeah, NASA has found this a new orbit that is different. It's highly elliptical, and it's going to be spending a lot of its time away from the moon and then swing in closer to the moon. NASA likes that orbit because it is very stable, and they believe that it's easier to get to, less power to get into that orbit, and from that orbit, it'll also be easier to reach different places on the moon. So, in fact, Artemis 1 will be injected into just that kind of orbit to sort of test it out and see how things work.
Okay, thank you. The second question is from Joe Pineda. Joe?
Hi, thank you for the wonderful presentation. My question is, are there any plans to park a communications satellite at the Lunar L2 in a halo orbit for relay comms to the dark side?
There are plans, not for the L2. This is where I would like to go, because the Chinese have actually placed a communications satellite to support their Chang'e 4 Farside mission, which is operating now. Instead, on our Lucy mission, where we were going to the far side, we will be carrying with us a communications satellite built by Surrey and funded by, in the UK, and funded by ESA. And it will be in a more traditional orbit around the moon, but that's going to be our communications satellite. Joe, you're raising an important question here, that in order for us to relay our data in comms back to the Earth, we have to have a communications satellite, because of course we're not directly in contact with the Earth from the far side.
Okay, thank you. Next question is from Ron.
Thanks for a wonderful presentation, Dr. Burns. I was looking at the animation videos showing the little rovers rolling out the very, very long antennas for low frequency operation, and then later on, the other rovers rolling out the arrays of dipoles. And I noticed that it appears that the antennas are laying on the ground. And I've been a ham radio operator for a long time and know that antennas, particularly in the HF spectrum and in other frequency ranges too, tend to suffer a lot of ground losses when they're close to the ground or even buried. And yes, they'll work, but they tend to be less efficient. I'm curious if that's being accounted for.
Oh yeah, Ron, you're diving into some of the details now, but you are absolutely right. We've spent a lot of time thinking about this because actually, if you look at these particular frequencies, and the soil beneath is a dielectric. And so actually, if you were transmitting, more of the power would go into the ground than above. But the fact is that the sky is so bright at these frequencies that we can operate even with those ground losses that take place. Ideally, what you'd like to do is put down a ground screen that would shield yourself, but that's too expensive and too complex for us to do. But we've done a lot of numerical simulations indicating that we'll still have plenty of sensitivity to be able to operate our arrays even laying directly on the ground.
Thank you.
The last question I have here is from Richard.
Hello. Thank you very much for that presentation. It was great. I really appreciate that. I was just wondering, with the radio telescopes, will the communication satellites interfere with them? And if they do, how do you get rid of that problem?
Oh, you also raised a good question. And that is, if we're not careful, do we end up polluting the far side of the moon with a lot of radio frequency interference, leakage from, we don't worry too much about the comms because the communication is at much higher frequencies, but just leakage from power supplies and computers on board could be a potential problem. The good news is one can put together a fairly simple Faraday cage, basically chicken wire, inside the spacecraft that would shield most of the electronics noise from leaking out. And so a little bit of preparation there needs to be done. So we are talking about this internationally. In fact, I'm giving a talk in 2 weeks at an international conference in Paris, but I'm going to be doing it by Zoom. And we're going to be talking, in fact, the whole conference is about how do we preserve the radio quiet of the far side.
Okay, very good. I see Mehmet got up and moved off screen, so I'll move on. By the way, you mentioned chicken wire. I went to buy some a few years ago and it was labeled poultry netting.
There you go. It works. It works as a powerful screen for low frequency emissions from satellites.
Oh, good. Good to
Something
know.
that
Good
simple.
to know.
Yeah.
I see Bradley Schaefer has a question. Go ahead, Brad, and ask your question.
Yeah, hi. You laid out a wonderful and ambitious plan for Artemis 1, 2, and 3. And Artemis 1 is going to be launched sometime soon. But you avoided coming out and giving even hoped for or expected dates for the launch of Artemis 2 and Artemis 3. What could you hope for?
Brad, you cut out a little bit there, but I think what we were saying is NASA actually does have dates for 2 and 3. For 2 in particular, they're 2024. NASA is still saying 2025 for Artemis 3. I'm skeptical of that. I think it's probably going to be more like 2026.
Okay, very good.
Go for it.
Yes.
Yes, yes. Do we have any other questions? Well, this was a wonderful presentation, very, very informative. Tell us again where we can see that video that we could
Yeah,
only
the planetarium show is called Forward to the Moon, and it's playing at the Fisk Planetarium on the University of Colorado campus in Boulder.
Okay.
Go to the website, just Google on Fisk Planetarium, and you'll see a regular set of showings. I'm going to be there live for the Observe the Moonlight coming up in October. When is that? October? It's like October 1st, if I remember correctly, this year.
Yeah.
So I will actually be there in person and helping to narrate the show and do some Q&A afterwards. But you can go anytime. It's playing, several times per week at the Fisk Planetarium. It's also, we've distributed it nationally, and so it's at a number of other planetariums. We've had almost 1 million views of that film so far, and it premiered in February. So we're really thrilled with that.
That's wonderful. I love Carrie Byron too. So good catch getting her to narrate.
Oh yeah. Well, we had to pay a few dollars for her, but we did a premiere out in Oakland at the planetarium there, and Carrie was able to come and join us for a panel discussion after the film. So that was great to actually meet her in person.
Oh, good. Very, very good.
Are you going to be involved in any of the missions to the Mars?
Not Mars. No, that's not my thing. The moon is, moon is what I'm interested in. That's where the radio astronomy is going to be. But I keep an eye on it. I teach about it to my students. We look at the forward technology and some of the so-called telerobotics that I showed you about our students are working on. That will have applications forward to Mars.
Okay.
Good. Wonderful.
Thank you very much.
Well, thank you all. It was nice meeting you via Zoom. I hope we can meet in person at some point.
Yes, I hope
Thank
so
you very
too.
much.
Thank you. Thank you very much. Okay, with that,
Very much appreciated.